Good afternoon, everybody. Thanks for being here this afternoon. Welcome to Ruby University, and thank NASCC for giving us the opportunity to present the constructability design philosophy to everybody. First things, as far as the PDH is concerned, the new program this year is to have the code and to enter it online at either the kiosk or when you get back to your offices. Today's code is AN as in Nancy, 91F. And I'll give that again at the end. F as in Frank, yes. All right, my name is Jay Ruby. I'm the President and CEO of Ruby & Associates Structural Engineers. Got my degree from Penn State University in the AE program, and been working in the building design and construction industry for over 20 years. And today's topic is a primer on constructability. And those of you who don't have the guide, it's a resource for you. The AISC is selling. You can get on the website, it's a philosophy, and we'll get into that today as to how you infuse constructability into your daily activities, how you deliver projects, how you think about projects. This is one of 4 sessions. The primer is going to be also given tomorrow morning at 8 o'clock. We have a constructability for designers. That's Thursday 10 to 11:30 and Friday 8 to 9:30. We have constructability for fabricators, Thursday 1:15 to 2:15, and then again from 3 to 4. And then we have a constructability for erectors, and on Thursday from 4:15 to 5:15. And just really looking at how the constructability philosophy can be infused into all the different aspects of steel delivery. And we talk about this as a philosophy. I mean, this is a design guide. It's published by AISC for designers in a series of design guides. But getting into the document and getting into thinking about a project, it really gets into covering a philosophy of design, but also reaches out to all the other disciplines within design. It's not just about steel, because we all know that buildings and structures aren't only about steel. People come back afterwards, put up siding, make it look ugly. It's kind of cool with it when it's all steel, but there's another purpose there. So the constructability philosophy goes across all different project deliveries, whether it's design bid build, design build, the new IPD, the CM at risk, kind of all different stages. You can put constructability philosophy to work on your projects. It really leads into collaborating as a team, collaborating as a design team, collaborating as a construction team, but collaborating as a whole building delivery team. When you have problems on the job, whether it's in the design phase, construction phase, or somewhere in between, the constructability philosophy helps you through that process. Gets into trade coordination. Trades that come before the steel shows up, trades that follow on after the steel, and what's the best way to coordinate those and work together, and ultimately leads to a whole teaming process on a project. So with that, Dave Ruby will be speaking. He, if I can find his bio here, he's a founding principal of Ruby & Associates and currently our chairman. He is recognized as a pioneer in constructability. He has served the steel construction industry for over 45 years. He's a graduate of Rensselaer Polytechnic Institute. He is our Dean of Constructability in our office, and he's an everyday practitioner of constructability.
The concept of constructability doesn't appear to be too much difficult. Everybody understands that what they design is built, whatever they fabricate is built, whatever they erect is basically they're building it. So what's the mystery? What are we talking about? What generated a design guide? What was the purpose of all of this? Several years ago, probably 10, AISC had a conference, kind of invited designers, fabricators, general contractors, etc., brought them in and said, okay, what's the issues? Why are we looking at things? What makes your decision? Why do you make decisions? And the comment came down was the fact that there seemed to be, and I think we all know it, there are silos of influence. Now, those silos don't become integrated. Those silos stand beside each other. So when the designer designs it inside his silo, he passes it on, he's done. Fabricator gets it, he gets it on. In some cases, he gets it done, and he passes it on to the erector, because those two are not necessarily a fab and erect team, they are different. The issue would be then, as you start doing that, your decisions are made on what I call first dollar based. In other words, the cheapest cost at the first time the thing I'm going to buy is going to be the cheapest way to do it. So the cheapest engineer will give me not the best design, he'll give me the design that's with that cost. Likewise with the fabricator, likewise with the erector. So if I take those three least cost products and put them together, do I have the least cost structure? Very likely not. So when we're talking about constructability, what we're looking to try to do is to give you an idea that in this design guide as to what we really are taking. And we're going to look at a little bit, we're going to take a little side trip to today's drivers of what is making decisions and what forces decisions. And then we're going to experience the concept of constructability, learn about what the benefits might be, and examine how constructability embraces sustainability and collaborative design. For those of you who have been involved in that, the word is coming. Sustainability is here to stay regardless of whether you want it or not, and therefore does it affect you? Well, in fact, the question would be is if the structure can be designed more efficiently, it will generate less CO2 in the manufacturing of the steel, and therefore you have benefits from there. But on the other hand, there are the leads points are being changed because presently right now, I think, unless where it's going, but the heavier the building, the better it was, because that meant that the cost was a greater percentage of the project, and if you're over 20% of the project, you've got leads points. But if you saved 50 tons, then you don't have 20% of the cost because you reduce the cost, so you don't get as many leads points. So they're going to correct all those sorts of things, but those are issues with regard to what we're doing. But let's talk about today's business culture, the culture that we live in, the culture that you're working on. Based on the competitive nature of design, bid, build, I am sure you will agree that this promotes adversarial relationships, that the cooperation between the parties is basically considered that's really not critical. I have things I need to do, and I'm protecting my issues, my liabilities, my insurance things, so I have done what I'm doing, and I am not moving to means and methods. On the other hand, the fabricator coming back on the other side, he has issues. Now he sees on the drawings, but his function with regard to bidding that project is he has to get low. So it's not any benefit for him to be the intelligent contractor, because then he sleeps well, but he doesn't get the job. So the scenario would be is the relationship we've generated with design, bid, build, but just by the nature of the concept, there's adversarial relationships generated. That's the relationship you're doing. Regardless of what your friendships are, those relationships exist within the unit. We have the happy couple. Many of you have been on both sides or one side. I've been on both sides, fabricator and designer. I've worked for fabricators, I've worked for erectors, I've been employed by both, been consultants to some, insultants to others. So the issue would be is there is a happy couple. That's the environment that design build is trying to live in. That's the environment that IPD is living in. That's the environment that most of the general contractors in the world can't get out of. Building codes. Why is that an issue today? Well, one is they're becoming more and more complicated. There seems to be a challenge to make them more complicated. But what really is the scary thing is that sustainability and green movement is getting the ear of building code writing individuals and committees. And the possibility of introductions into the building codes for maximizing energy consumption, or maximizing usage of electricity or maximizing the usage of plumbing will become part of the building code, not necessarily life safety issues, but cost issues. Sustainability. Sustainability is an issue that we sometimes think of as it's strictly on the green side, but in fact there's an environmental component, there's a social component, and there's an economic component. And all three of those have to come in to make it a sustainable development. And it's a balancing act. And we're not used to doing this. Our designers aren't used to doing this, primarily because in order to do this, you need to talk to other people. You actually need to know what it costs to put something together. You need to know how it impacts that. So the decision on first dollar cost as to whether the Kohler plumbing is the best plumbing for you to buy is not necessarily the correct thing. The other situation is do we decide we use a moment frame system because that's what we want to use? Well, maybe because of that and the depth of the beams, that causes impact on the sizing of the mechanical system, and therefore we actually make it more inefficient. So therefore it has to change. So the scenario would be is this really is telling us that collaboration is necessary in our design process. Sustainability design, as it's defined, is a trend that deeply consistent with the principles of integrated project delivery and building information modeling in particular. Now, I'm sure everyone in the room has had building information modeling in one flavor or another. The scenario I'm concerned about is that we have owners asking for building information modeling and have no idea what they're asking for. And there is no guideline at present that says this is it. So for some cases, the Tekla model given to the mechanical contractor so he can do his piping, and then they run it through Navisworks so it doesn't clash. We got BIM. In other words, in other cases, we start with a Revit structure model which introduces the structure, then introduces mechanical, and introduces the fire protection, and introduces the walls and the ceilings and the steeling and the hinges and all the exit lights. Then we have a BIM model. So when they want a BIM model, what do they want? Friday, before I left the office, we got a call from one of my clients. They have finished a building. They're a general contractor that does their own steel erection. They're finished with the building. The owner said, you know, I think I'd like to have a BIM model of this building. So if they don't know what they don't know, it's difficult. We all have to do some education. Sustainability, in the same case, though, starts to look at other things. Natural resources, energy, financial, capital, human people, life cycle. Do any things sound familiar that you really were using this over in your design process? I don't think so. But if I look at the common elements of sustainable design, it's a delivery approach that adopts collaborative means, beginning in the early stages. Because if you don't do that, then you start to force fit things, and it doesn't come out to be the issue, the question, the total working issue. And when we're talking here, cost is critical, schedule is critical, but low cost is not necessarily the goal. The issue is to meet sustainable design guides in a plan that is economical, not necessarily least cost. I have project delivery systems. They keep changing the names of these because one of them doesn't work. Okay, back in the 70s, CM was the way was going to solve the world. Had everything all taken care of, and so it amounted to the fact that we found out that CM, a couple practiced it. The rest of them practiced like general contractors always did, but they just call themselves CM now. Then we had several others. Design build comes in and out. Who's designing, who's building. Then we find that, well, okay, we'll do design build this way. Instead of the owner hiring the engineer and the architect to design the structure, we'll be the GCs, we'll hire the owner and the architect, and we'll put everything out for bids. Just the same. Is that design build or the philosophy of concept? Not necessarily true. And do you get the best operation? Well, the difference is who's pulling the train. On that design build, the contractor's pulling the train. So the question would be is we change that. So we had lean construction, and I'm sure all of you have gone through that, or partnering training, and you had to have partnering meetings every week, and you went through all this stuff. Well, I don't hear a lot about it lately because it's not really the popular thing. So now we have AIA has published IPD, Integrated Project Delivery. Contractually, they're going to have you all sign to a contract. Everybody's on the same contract. There is no risk because you all share it. I don't understand that. Certainly, my insurance carrier doesn't understand that. But it exists, and it is a concept of collaboration. If we go away from the ideas of the contract issue, but look at the concept of doing the design, it brings people together to solve issues. Design build, we've done that. Design bid build, let's talk about that one. Some would call it design bid build. There's others who would call it design build bid hope. Especially if you go to a bid with only a 1,000-ton hospital, and you go there and there are 16 fabricators and 12 erectors. Is design bid build the proper term? May not be. If we go to design build, it's another sandbox. The question was, what shovel do you have? Are you armed to be in that business, and how do you get there? Integrated project delivery is the same process. It's other means to do it. If I look at these, if I have, based on information to a project, I can have more of an impact on the cost and on the functionality of that project if I provide the information early. On the other hand, if I delay in generating that information, the cost becomes almost, goes to its roof. I don't have it. Traditional design, however, falls in the wrong location. We're well down the curve of concepts of value review, of constructability issues, of determining whether the site is properly situated on the site, or whether the mechanical system is proper, or the structural system itself, is it the proper? We're here. You start making changes, you get killed. The IPD process indicates what they would like you to do is to move that decision up this direction, more into the higher range over here, and therefore have benefit for the project. The whole concept of that is that you have to have collaboration, and how do you generate collaboration? Well, what I would say to you is, are you shovel ready? Because all of those processes, whether you like them or not, will be where you are. One way, sooner or later, you're going to get some of that sand in your shoe. And I'm going to get to where my slide is here because I went a little past where I was flipping. I apologize for that. But anyway, the business climate is changing. The steel industry faces choices. You have 3 sandboxes that basically you're working with, or you're designing for, or you're engineering for, or who in fact is going to correct you if you're an erector. And the truth is we will probably end up playing in each one of these boxes. And your business strategy, which I think is something you didn't expect to hear out of constructability today, but your business strategy is significantly impacted by the sandbox you're playing in. And if the question would be, is the game is changing. So are there common elements in these 3 elements here? Is there something that we can say it's okay to make a difference, which box we're in, that we can do things similarly? Well, in design build, there is and are elements of collaborative design. It can be that type of process. It partially integrates the design team, not wholly but partially. It encompasses many of the attributes of lean construction, which we really haven't seen that too much, but in basic concepts of it. But it also engages more of the project participants. But probably better yet, it's really cost and schedule driven. Whoops, hit the wrong button, sorry. But if I look at IPD, I get some very similar issues. There is a collaborative method of design. Forgetting whether the system is good or bad at the moment, but the concept, we need to think the concept. It integrates the design team. It encompasses lean construction, and it contractually, right now, engages all participants. But it definitely is cost schedule conscious. It doesn't mean that we're first dollar conscious. It means you're cost conscious, schedule conscious. So, the two elements we looked at was sustainability, which really doesn't have anything to do with the delivery method. It's the end product. But we have delivery methods of design builder or IPD. And we'll find out that, in fact, from a philosophical point of view, that's what constructability has been saying for years. I didn't coin the word. There's an organization in Texas called the Construction Industry Institute that have performed some studies. They're affiliated with the University of Texas at Austin. They've been performing studies since the 70s. In the mid-90s, they came out with a concept of constructability, indicating that what that in fact brings to the table and where it goes and what it can be done. And in fact, it talks about collaborative methods, integrating design team, and bringing participants on board. That's a concept that was taken some time ago. Getting back to the drivers, we have technology, and all of you, we've talked about BIM. Where is it going to go? The question I have is, how do you retain knowledge? Example I will use as when I started working, I was in a draftsman. I was doing detailed drawings for American Bridge, and I had a drawing for my first drawing. It was put up, and this checker, I think he cut his finger or his throat or his wrist or something, but that drawing was read from one side to the other. So being a typical smart-ass engineer, I saw this drawing and I said to myself, well, shit, I can redraw that faster than I can scrub it and check it. So I proceeded to start to redraw it. My superintendent came by and he looked, what are you doing? I said, I'm correcting this drawing. He says, no, you're not correcting the drawing. You're redrawing it. Well, I said, yeah. He said, well, no, you're not going to do that. Scrub it. And why? Well, because I will tell you, I never had to scrub another drawing that extent before. I understood what I was doing and what I was not doing. I retained that energy. Now we have a drawing that's made on a CAD machine, and you want to change it, you just hit delete. You have no ownership. Besides that, you also have no retention of what you did yesterday. Now, in fact, we've got technology that we're all going to get together, and we're going to have mechanical, electrical, and everyone sitting around the room, and you're going to work out your issues, okay? And you're going to generate this structure, which is building a facility model. You have it all done. And I will ask you 6 months from now, who in your organization will have any clue on what those discussions were? What was your decision-making process? What were the do's and the don'ts? How do you get ahead from here? What do I do on the next project? We have a knowledge transfer gap that's going to get larger and larger. And technology, if it's not bridled in, is not going to help us. But we have all of these things. We have Twitter. We have LinkedIn. We have, they're falling over themselves. The question would be are they toys or are they tools? We need to decide that. BIM, in fact, has the ability to go from 3D, sorry about that, get back there. Has the ability to go from 3D to 4D, picking up time, and 5D, picking up cost. That can all be done in there. But what I'm finding now is I have contractors that are doing that. They're making their own model. They're not using the BIM model from the engineer or the architect. If it's not there, they're making it themselves. Some of them are doing it even on the estimating stage, so they can actually plan and schedule their subs, etc. It's a tremendous tool, and can be considered in all of your offices for that type of work. BIM, what I'm indicating to you is BIM is a tool, it's not a solution, it's not a process, It is strictly a tool. It can't, you can just do alternates, you can look at that, you can use it as a tool, okay? I'm saying myself that I had a 1-week course in slide rule. And if I didn't know it, if I wouldn't learn it, I couldn't have got out of school. The question would be is, do I need to have BIM taught to me? Do I need AutoCAD taught to me? Those are tools. So it's not a process. It is a tool. As I said that already, I guess. It's not a design process. It's not really process improvement. It's been driven down on us, and it's looked upon in most cases as though it's a substitute for delivering shop drawings or delivering design drawings. But in fact, it's a complete design, totally complete 100% difference. It's not a substitute. It can only enhance the quality of the project delivery when paired with integrated and collaborative design processes that everyone's involved with, that they're moving ahead with. The last of the drivers, and it's last because I can look at all the rest, and all the rest are like apple pie and motherhood. We can't really argue with them too much, but when your decisions are made and the rubber meets the road, cost and schedule. But the interesting thing is here, it's not necessarily what it used to be, initial costs. You've got operating costs, maintenance costs, deconstruction costs, and recycling. That is working into the sustainability issues as to where our costs for the structure are. So our industry, our industry has been focused here forever. But we're not there now. These other elements will be, in one way or another, part of the process. They are going to be part of the process. We are not going to be able to keep them out of that process. They will be there. And so, as I would like to indicate, that I believe constructability is the common thread through everything that you've looked at today. Constructability is a concept, a philosophy that allows you to visualize, that allows you to see. It includes BIM, it includes design, it includes leads, it takes sustainable design, integrated project delivery, whole building design, carbon footprint, whatever you want to call it, however you do it within the system, it is part of the process. Sustainability, collaboration, integration, cost and schedule. Those are the elements that we're making decisions on. If I look at the traditional design process, in my opinion, it's reasonably fragmented. Constructability, we call it integrated. If I go with traditional, we have silos of knowledge. We have designers, we have fabricators, we have erectors, we have GCs, we have plumbers, we have painters, and everyone stays in his own silo, and they do not communicate other than passing the page from one chair to the next. But in constructability, what I'm indicating is that project that is a team focused and it's integrated. So you actually sit down and make this. It would be helpful for engineers to listen to the mechanical engineer's issues. Maybe the difference in that beam size changes his mechanical processing equipment, or his horsepower, or the efficiency of the system. But yet, what happens is a structural decision is made many, many, many weeks before he's involved today. So when he comes, he has to live with what he has. If I continue down, traditional is kind of individually managed. Constructability is maybe collectively managed. Now, concerns me on that is that it's everyone's responsibility, is it anyone's responsibility? And the issue would be, yes, within your collectively management, what you do have is that you are responsible for your areas, but the decisions are made, so everyone is reading that decision. The decision's not made in the closet, it's made in the meeting. It's traditional. First, cost-based. Constructability. value-based. Now, I would ask you, as a fabricator and erector, would you prefer to be called the low-cost fabricator erector, or would you prefer to be called the value-added contractor? Traditional, very formal, very paper-based, constructability, very open. 2D documents, traditional, which we're forcing BIM on us. I say over here we're looking and we should be moving towards shared 3D models. I have no idea yet why I should be afraid as an engineer to share my model, any more than I should be afraid to issue 2D drawings to you. If there's an error on it, there's an error on it. And that's what there is. I see this as traditional unilateral efforts. You allocate transfer risk. Oh yeah, it's not mine, it's yours. And there is no sharing. Over on this side, we would hope that we would encourage, foster, promote multi-level, open sharing, collaboration, and risk sharing. Now, I agree there are people, there are insurance out there that aren't going to like this. I'm saying, and I say there's issues there. I agree with that. There are some things we need to do. But that doesn't mean we can't collaborate with regard to, if you have a trusted partner, you don't go into this with the first pretty skirt you see coming down the street. You go into this with someone that you have a relationship with, someone that you've worked with, so that you build on it. You're not going to start on this over tomorrow. Now, I showed you a little bit before, influence of curve. This one's a little more specific, but we're talking about during the concept and feasibility stage. I mean, I have almost 100% chance of providing knowledge to the structure or knowledge to the system, whether it be structured or not, and therefore to maintain a reasonably good curve of influence if I can do it there. Likewise, the curve goes that direction. Now, if I go back to the Constructability Institute, this was their definition in 1989. The optimum use of construction knowledge and experience in planning, design, procurement, and field operations to achieve overall project success. Now, the only way that you could do that is for there to be construction personnel on the design team, not at 30%, not at 60%, not at 90%, but the whole thing. Now, how do you do that? Well, I think through relationships, and there's a cost there, but there's also a benefit there. Now, is it possible that that construction professional that would be doing this, he may not even be the bidder, right? There are those of us, myself plus others in the industry, that basically spent 20, 25 years in the fabricating business, and we know that. And we know costs. We understand those things. So that type of input is one of the ways you can do it without committing to a fabricator. But on the other hand, if you have a good fabricator and you can do it, the question would be is you can get better numbers. You can get better numbers from quality contractors. So, I would say, as I indicated, a truly integrated design team would include some sort of construction professional. Now, who he is, how he's done, would be your individual issues, your ways that you would generate it, people you know, who you have experience with. But I would tell you that constructability, as I've indicated to you, is not value engineering. Value engineering is like the light on your dashboard that comes on and says check oil. It's too late. Value engineering is a pain in the ass. That means the engineer of record has to go back and do something. He is insulted because you have corrected his design. You have said something to him which, in fact, he's got his blood and soul in that. He's got 80% in it, and he really only gets paid to design it once. He did it. He worked with the architect. They did a concept. They designed. He's done. He's done his work. He's only done it once. Concern is the issue with regard to it that statistically The best idea is not your first idea. It's somewhere between the third and the fifth. So if you are a designer and have not had the time to cope with the architect, there's a very good chance that your best idea didn't hit the table. It's not means and methods either. And the fact that engineers rely on means and methods to not define things on documents, I think, is in error and does not do justice to their profession. We need to have an understanding in fabrication that what we're designing, in design, that what we're designing can be fabricated and that it can be installed. It doesn't necessarily have to be the most efficient one. I agree. It doesn't have to be. But it certainly ought to be buildable. There's not constructability reviews. Constructability reviews, which I see, you can scan on the web to find out, search constructability reviews. There's 2 or 3 dozen people who do constructability reviews. You sign a contract, they review the drawings of 30%, 60%, 90%. They'll come back and give you responses back and forth. Now, what I'm indicating at that point in time is that if you wait till then the design is only a critique of what you did. It's not a critique of what you didn't do. If I started back here, then we critique what you didn't do and what you could do better. Constructability then begins in the beginning. And it's a continuous process. It is not an event. So for 2010, the definition gets expanded a little bit, indicating through a collaborative team effort in the planning, design, procurement, field operations, and building operations to achieve the owner's overall facility operation and maintenance objectives. There's a whole new element into that process today, and we're going to be living with it as we move forward. So, what are our primary drivers? As we looked at it, I'm sure cost and schedule is definitely there. But for the designer, it's time and dollars. But for the fabricator, it's another element. He's looking at numbers of pieces, complexity of details, before he gets to his man out. So what's in it for you? The question would be, is if I'm at the front end with the GC and the CM, contrary to popular opinion, they can increase their profitability because they will enhance opportunities that they have by doing the process. For a fabricator or erector, it can give you a competitive edge. You can become a value-added provider. For the design firm, you can reduce RFIs. You'll enhance review and the approval process. It won't take you long. Your construction administration improvements, costs will significantly decrease, and your image of on-time and within budget projects will go up. That can't be bad. But let's talk about real numbers. Numbers from studying of over 100 to 150 projects. $20,000 investment in value engineering. $100,000 to $400,000 in savings. For $200,000 investment, $1 to $4 million in savings. And this is records from projects that actually exist. Oh, okay. I'm sorry. Okay. Apologize for that. Okay. So, when do you start these connections? When do you make these decisions? Here's a simple one. Very simple discussion. What connections are we going to use in this job? What type of bolts are we going to use? We have a 52 kip reaction on a single shear bolt, single shear plate. 1, 2, 3, 4, 5, 6 bolts. If I decide to let them be snug tight, I'm going to have 3 bolts with the threads excluded from the shear plane, and the cost is about $21. If I put the threads in the shear plane, it's going to be $28. If I say to myself, well, I'm going to use bearing bolts, but I'd prefer them to be, I don't like snug tight because they might come loose and I'm not sure how, but anyway they might. So we're going to pre-tension them. So now that $21 becomes $31.50 and the $28 becomes $38. But if I decide to put slip critical bolts there, the cost is $68. That is not a simple, casual decision. That's a dollar cost decision, and this cost is only related to the bolts. All right? That's what the installation, fabrication, cleaning, etc., what has to take place with regard to that issue. So, indicating that to me is a decision, that's a cost decision, but that's also a schedule decision. We have one project we got involved in. The original project had 44,000 bolts. We modified the design, the connection design issues and changed it to 21,000 bolts. Does that relate to man hours? Does that relate to schedule? Absolutely. Some time ago, we had a contractor who was in the design build business and was tracing some of the hangars around the country. He sent us a hangar design that he had already bid on a project and he had lost. And he sent it to us and said, what can you tell me? What are my options for this building? What else could I have done? Well, in this particular case, these bays are 30 feet. There are 11 trusses, and there are 786 joists that are about 30 feet long. There are 144 bottom chord braces with 228 connections. And we have 145 struts, and those are the bottom chord struts, and 290 connections. If we look at it with a 40-foot bay, the building's not quite the same dimension, but it's very close. We now only have 8 trusses. We don't have 11. We have 576 trusses. That's less. We have only 72 braces. That's half. And we have 74 struts, 148 connections. Looking the other way, the 30-foot bay has 11 columns. The 40-foot bay has 8. The 30-foot bay has 40 diagonals. The other one has 30. The one has 53 drag struts, and the other one has 35. That's a typo. I apologize for that. Just noticed it. The other one has 111 joints in this bracing system, and the other one has 79. Understand that once you put the siding on this building, you can't tell the difference. You can open the doors or close the doors, do what you want, let the snow blow, let the wind blow. It doesn't look different. Trusses. 30-foot trusses, there's 11 of them with 14 panels and 55 shipping pieces. On the other bay, there's 8 trusses, 10 panels, 40 shipping pieces. Tonnage, you could throw a blanket over the difference in the tonnage. Where's the cost? So we did an extra one. What if I did a 60-foot bay? I only have 6 trusses. I got 450 joists, 102 braces, 36 struts. So when I look at the 30, the 40, and the 60, understand I can put the siding all over those buildings and you can't tell the difference. They're the same. There isn't anything wrong with the structure of any of them. But if you look at the diagonals and the pieces, because the fabricator, although everyone uses dollars per ton, that's really not a meter for a fabricator. They buy steel by the ton. That's the only thing they buy by the ton. Everything else, they take that cost and then they add to that man hours for painting, shipping, handling, cleaning, drilling, welding, bolting. Just man hours, man hours, man hours. We're here, we're looking pieces, pieces, pieces. That's a cost. Major function. This is a constructability issue with regard to it. There's nothing wrong with the design. The design will work in either one. The Question would be is, if I have this knowledge and understanding to ask the right questions, I can move to the next area. Maybe you'll look at it in the past, before you came in here today, that constructability was simple connections and simple construction. It was bolted versus welded. It was minimum temporary bracing, no shoring required, no special procedures required. That you went through 30 and 60 degrees and 60%, 90% documents and reviewed them, made your comments, made the guy feel warm and fuzzy. You're maybe even involved with some trade-specific design assist services. Now, how do you want to sit down and tell the engineer that you don't really think his design is what you need to be? So what you're really only going to tell him is what's kind of smoothing, because he is going to be approving your shop drawings. So you can't possibly get to that point. It doesn't work. It may be some of all of that up above, but we believe constructability is a design philosophy, and it's much broader. 4-story, 150,000 square foot hospital. What can you do with that? Well, if you meet on a regular basis with the design team, mechanical, electrical included, fire protection, etc., and work out the project, what we have here is a project that was built 2 years prior. The owner in this particular case had an idea. This idea was 5 years ago. He did IPD. But the only exception is we didn't all have a signed contract. What we did was get together, and the contracts were negotiated based on designs as it was completed. But he believed he had the contractors. He had been doing this for a while. He chose contractors he had trust in. He said, gentlemen, I want to do this. Well, designs, 10 weeks, same time, same hospital. He saves just shy of $500,000 and pared 17 weeks off the construction schedule. It amounted to about $3.75 a square foot. We say it's a design philosophy that's independent of the delivery method. You can use it in design bid build, we can use it in design build, we can do an IPD. The question would be is to get the knowledge infused in your design decisions, and don't fall into the trap that you have to do what you have to do because you don't have time. We just saw a project where 17 weeks at the end.
Does that include the phase? Does that include the cost and money and the fact that they can be in the hospital generating revenue?
I do not have that on that slide. That is the construction cost. The revenue for the building is additional. Yes, true. Another one. It's a 105,000 project built down in Georgia, and at $4 million, it was not going to be built. The owner, with a contractor, asked us to review and get involved on this project, and what can we do to make it happen. In this particular project, what came out of it was about $800,000 and 16 weeks less than the schedule. And that included 6 weeks of redesign. Now, the design, what we're starting here at this point is this is starting at designed. That's where it was. That's what we have. The question would be is decisions were made on this project that were not correct, that impacted the quality, or impacted the design of the structure. And yes, there was tremendous opportunity for those type of scenarios. But what I'm indicating is that the bringing of the construction knowledge in, the initial contract should have been $3.2 million and would have been built in 28 weeks. So The option of the knowledge, if it's brought in place, can make a major difference. The design philosophy we have includes visualization, innovation, imagination, clear, concise project visions, concepts and attributes, clean slate concept. We don't come into the thing with preconceived notions. Most of you who have ever been involved in any sort of, brainstorming sessions, that the worst thing you can do in a brainstorming session is start taking shots at the first idea that's thrown up, because then people say, well, I'm not going to get picked on. Don't do that. In those type of sessions, what we do is you bring them up and everything sticks to the board, and then we start evaluating where we can go. But you need to have collaboration and coordination, designer and constructor communication. That's a new, very radical concept. All designers from all construction trades. And you have to maintain the vision. You can't back off from it when we get down the process. So all of this is really done through coordination and collaboration of the process to making sure the people and the individual is there. Institutional building. This one's kind of unique in the fact that the first one, we had a little budget issue, 3 stories. Construction, 38 weeks. Redesign, 4 weeks, $2.6 million. But it's a 4-story building. On the first one, the 4th story was an alternate. It was an add-on to the $2.8 million. Wouldn't fly. Redesign. Value analysis. Complete review, but it was based on constructability and timing. This particular project was built about 4 years ago, 3.5 years ago, when steel prices were just changing on a weekly and daily basis, when there were surcharges, etc., etc. What we did with this building on the redesign is we sat down with the fabricator who was involved, we were teaming with it, and he put his whole, here's my inventory. How do we get through it? Design philosophy is a process, not an event. The infusion of construction knowledge and experience in the planning, design, procurement, and installation, with cooperation and collaborative design, including all trades. $1.2 million square foot hospital that's presently being completed. We changed the lateral system in this hospital at the request of the general contractor. This did not come from the fabricator. General contractor, this has a concrete core walls 2 foot thick, plus or minus. And based on, we're building this in Detroit area. Concrete work in Detroit area is not what you want to do. It doesn't mean you can't do it. It just means you probably ought not to. Schedule-wise, we're talking 13 months for this particular phase of the project. They came back to us and said, what can we do to modify that schedule? We looked at changing the concrete core to steel. We had some time working with the architect and engineer to get that done, but we did take it over. We did not change the architectural at all. We fit the steel inside the 2 foot wall plus the drywall on the outside of it. But we managed to remove $4.5 million out of the project and reduce the construction time by 3 months. Now, would this be the answer in Dallas? Probably not. Would it be in Georgia? I don't know that either. What I'm saying is, in constructability, the issue is there isn't a solution. The solution has to be with the people, time, availability of materials, availability of talent, availability of equipment, site, access issues, all of those things, and none of those are on the designer's decision matrix, but they should be. So this constructability process, if we go through it as to what it does it mean, you really need to evaluate your client and your project needs, and can you convince him that the additional costs up front, which there will be on this, maybe 10, 15, 20% additional in your design fees. Include the industrial experts on the team, perform site review, and in some cases on here, there's some negotiating what you do. Who is the expert you bring on board? Is he contractor related or is he not? Is he a consultant? There's options, but we want to look at things that aren't in that design decision matrix, and one of them is the site review. Access, truck, laydown, lifting space, where's the crane go? Is there room? Is there time? We find that sites will oftentimes be so congested that you're erecting off the street, and you can only erect off the street from 10 in the morning till 2 in the afternoon, and after that you're done. I mean, it exists, and yet is it necessary? Some cases it may be, but seems to me oftentimes we get into those cases and we don't need to be. I have a series of things. Confirm local labor and skill availability. Absolutely. Collaborative design includes industry experts, but we need to keep the owner involved in the project team with regard to the whole process. And from constructability process, we've come to this point in time. I thank you for your attention. I am interested in comments. We've got a little time left. I've got 5:30. We've got about a half hour. And I need to stay by the mic because it's being recorded. They came in and reminded me of that. I apologize.
Really familiar from Clean Curve, the concept of moving decisions earlier on in the process. And I fully adhere to the idea that it really is a process throughout. But really with the way technology is headed, you see them and these other tools enabling more change later in the process. Because I think owners are going to continue to want to change the building. Owners are going to want to make new decisions, and design teams are going to have to deal with that.
I think you're correct.
More changes
Right.
until we get to construction.
The concern I have with regard to that scenario would be the fact that once I get the mechanical and electrical and the plumbing and the fire protection, etc., and I start making corrections and changes, today, when I do that during the design process, it's not as devastating as it can be because the plumbing and the mechanical, electrical are normally downstream. BIM is bringing them upstream. So when they bring them upstream, the possibility, the impact of corrections and changes by owners is going to be, I think it's going to be more costly than it even is today. And I'm concerned about that issue, and I mentioned earlier about the knowledge retention and how do we do that, because my feeling is there's and I don't know how you do this, but the owners need some education. Because they don't understand, they don't see drawings, they don't see the design, all they see is the foundation in the ground, so why does it take me so long to put it there? And they also say, well, you guys have been designing buildings for hundreds of years, why is this a new experience? Is this, you've been doing it, why don't you just pull it out of the drawer, right? So, I see BIM causing that, even shrinking that, and making it more difficult. I say it more difficult than easy, even though, because it's not a button pushing thing anymore. Yes, sir.
We've been doing this for a while. It's really gone a long way in educating owners and working in collaborative ways, but it's really gotten stupid the way we come in.
Yes.
The owners are throwing it all away and just going out and getting the roads in. It's all digressed significantly in the past 2 years, and I think it's going to take another time before we get back to where we were 5 years ago.
It may very well be that way.
In New England, right?
Yeah, there's a lot of as I call it, first dollar. There's a lot of first dollar decisions being made, and The only thing we see is a significant amount of issues with regard to sustainability and the green movement and things that need to take place. For one of the examples we looked at, and it was not our project, but a project out in California where by the fact that they did some extra investigation and developed and used a dampening system in the design of their structure, they were able to eliminate over like 500 or 600 tons of steel, which in fact gave them extra kudos because of the reduction in CO2, etc., that was done and generated. So I see that as being kind of a little cloud that's going to follow us around as a steel industry, that we need to really work on that, because first off, if I take a ton of steel and I want to recycle it, I will get 1,960 pounds of steel out of that 2,000 pounds that I'm recycling. If I take a ton of concrete and recycle it, I end up with about 200 pounds of road fill. It is not, I mean, did I use it? Yes. Now, it's under the road. Can I use it again? Probably not. But that 1,960 pounds of steel that I recycled, I can recycle it again, and I can put that building back up again. So steel is about 98% recyclable, and it's only said it's 98% because the other 2%, we have alloys they have to move in to make the steel what it is. So I think in the steel industry, you're going to need to know those facts. That's going to be part of your sales issue. You sell man hours. I think you're going to have to sell knowledge. I think you're going to have to sell and understand sustainability, constructability, issues with regard to what it takes to make a pound of steel, what are the process with regard to it. There's an interesting presentation that AISC has generated over things, but I started in the steel industry back in the 60s. We were doing, I think, 13.5 man-hours per ton of steel. Today, it's less than a half a man-hour per ton of steel. Although what they have done with regard to their pollution control, etc., with regard to the industry is amazing. So we're not, that is going to become part of the process. I think sustainability, what we see right now in the green movement is, the impact we see is mostly mechanical, electrical systems, air trains, air issues, etc., with regard to it. But it's interesting enough to know that that a concrete building may, not necessarily will, but may actually give you issues with regard to the heating and cooling cycles, because concrete retains heat and it retains cool. So if you're in an area where you've got wide movements of the sun and issues on the building, the cost to air condition it and heat it are likely to be more than they are if it was a steel building. There are other issues with regard to it as to whether it's the exterior surface and it heats on the inside, so you have to do certain mechanical things to drape that interior. So those things are going to be needed to know within the industry in order to move forward, and all of that is going to fall into constructability information that's necessary at the front end. And the designers are not going to have all that information because it's not available for them. Yes, sir.
I think, hitchhiking on what you just talked about, Dave, the sales issues is really the part of the issue that he and I are facing, the gentleman in front of here, because it does become a market point, and that is developing the trust between the owner and the construction team that in fact you are operating in his best interest, so that your goal is to try to eliminate the silo concept that you described. Eloquently, I might add. I hadn't thought about that, but that's absolutely right. And for us to collectively, within the entire team, bring that trust to the table so that that owner can feel comfortable that what he's getting is going to meet his goals and objectives, both financially and schedule-wise. But that's our biggest hurdle is marketing. I mean, the empirical evidence is there. I've never had a problem with that. It's convincing the guy on the other side of the table.
Right. There is a difference.
The group of people that either I bring to the table or that the contractor brings to the table, and it may be me or it may be somebody else, that's what we're up against. It's a marketing issue.
I agree. It isn't a marketing issue, and let's say there's probably even a bigger, well, not a bigger one, but there's another one that's kind of looms up here. CMs, designers, structures are, so steel is so many dollars per pound. Fabricators don't do that. They have man hours, they have issues. The question would be is, what is the dollars per square foot, not the dollars per ton? What are we going to take to make this structure up? And I find that what happens, we've got some examples in our couple of other presentations on one project that makes a significant difference in the design, and there's 4 different options on this project. And it's a study, okay? And the costs vary by several, well, $30,000, $40,000, $50,000, but the cost per ton are $1,900 at the low end and $2,100 at the top end. Okay? But the cost per square foot goes from $8.80 to $13.75. That's the difference. And we're not selling. I was in the fabricating business a long time before I was in the design area, and I know of presentations, we filled the screen with dollars per ton of this, and this was hospitals or this much ton, and structure, high-rise buildings are here, and this stadiums are, I mean, I just said, I just goes over and over and over in my head, and we were, we're not selling that, we're selling man hours, pieces. But in generally speaking, in dealing with CMs, etc., in their market, and what they're doing is they have a history of dollars. Now that's accurate money. That's accurate estimate concepts. I understand all that. The question would be is, you can't apply it just universally to that structure because we don't know what that structure really looks like yet. So until I know what it looks like, I can't make the decision as whether the braced frame should be a chevron brace or an X brace, or should it be a moment frame, or should it be a composite system, or should it be a united system. I need to look at the site, the structure, the installation, the erecting, how I do all those sorts of things that don't have anything to do with the design and aren't on the design decision matrix. And what I'm trying to get across with constructability is that the design decision matrix needs to expand. It needs to be done. And how do I do that? I have to get that information input on just what you're saying. There needs to be trust. You need to do that. We can't do it overnight. But I think if you end up with success in that area, then you feel a little more comfortable and you can do those sorts of things. But essentially, I believe you can make more money. Okay, I think you can all make more money by doing that. Especially when you're on time, and you've eliminated the claims, and eliminated the litigation, and eliminated all the RFIs, because we never have time to do it right, but we always have time to change it. I think we ought to take the time to do it right. So, and I believe, even with the added cost, you can make more money. So, if there are any other comments and questions, we are going to be doing it. Each one of these presentations kind of moves in a direction, gets a little bolder. This one is probably the overall concept and ideas. There's probably not a lot of meat here. We were trying to intrigue you with the concept and hope that you will stop by tomorrow. We have one for designers, one for fabricators, and one for erectors. Jay, do you have any wrap-up?
Just go on the next slide. Today's presentation and actually all of our presentations after the conference is over, we're going to have a website, rubyuniversity.com. We'll have all our presentations there and articles that Dave has written, I've written, our staff have written about constructability that have been published over the years. We're kind of going to have a informational clearinghouse website dealing on constructability that
beyond the talks here. Some of them are deeper case studies, some of them are philosophical writings and that kind of thing, but to help with everybody's understanding of what we think constructability is. So, and does everybody have the code for the PDH? Anybody need it again? All right.
Yeah, you put it in there anyway.
Oh, I'll give it to you anyway?
Yeah, give it in.
It's letter A, N is in Nancy, 9-1, F is in Frank.
Thank you, gentlemen. Have a great conference.